Good morning, everyone. We will start with some grade 10 revision questions just to check that you remember how to simplify exponents. Please will you make sure that you have downloaded the worksheet from Moodle, and I'm going to be starting with exercise 1, question 1. We have xy in a bracket squared multiplied by xy squared all over y squared in a bracket cubed. When you tackle a question like this, remember to first deal with the laws that enable you to get rid of brackets. Xy in a bracket squared means x squared, y squared. The power belongs to both terms inside the bracket. At the bottom, to get rid of that bracket, you are going to multiply exponents, so we get y to the power of 2 times 3, which is 6. First of all, we are going to multiply our like bases by adding exponents. X cubed, y to the 4 divided by y to the 6. Now we are going to divide by subtracting. And we get x cubed, y to the power of minus 2, or we can present that answer as x cubed over y squared. So, just to recap, first of all, deal with the brackets. That rule is the rule that says a power outside a bracket belongs to everything inside the bracket. Here, to get rid of that bracket, we use the rule that says when we are getting rid of a bracket, we are going to multiply our exponents. Then the rule that we've used here is where you are multiplying like bases, you add your exponents. And here we use the rule that says when you divide like bases, you subtract your exponents. Also, remember x to the power of a negative exponent is 1 over x to the power of a positive exponent. The second example that I want to do also comes from exercise 1. And here we have x squared to the power of n minus 1 multiplied by xy to the power of n. The reason I've chosen this example is I want you to remember that when you multiply your exponents here, it's really important that you're multiplying the n and that minus 1. So here we get x to the power of 2n minus 2 multiplied by x to the power of n, y to the power of n. Now that we've got rid of our brackets, we use the law that says to multiply like bases, we add exponents. 2n plus n is going to give me a 3n minus 2 times y to the power of n. I would like you now to pause this video and to do exercise 1, questions 2, 3, beg your pardon, and 4, so that you finish exercise 1. Sometimes when we look at an example like this, you will see that ostensibly it looks like we don't have any like bases. However, that 15 can be factorized into the prime factors 5 times 3, and that's to the power of n plus 1. When you factorize your composite bases, it's really important that you put that bracket in so that you remember that both the 5 and the 3 are multiplied by that power or raised to the power of n plus 1. At this stage, I can now multiply my like bases. I am simply going to add my exponents. N plus 1 minus n gives me 5 to the power of 1 multiplied by 3 to the power of n plus 1, and that's as far as we can go. The second question from exercise 2 looks as follows. We have 4 to the power of x minus 1 multiplied by 8 to the power of x plus 1 all over 32 to the power of x. It's really important that you take the 4, the 8 and the 2 down to their prime factors. So instead of a 4, I'm going to write a 2 squared. Instead of an 8, I'm going to write a 2 cubed. Instead of a 32, I'm going to write a 2 to the power of 5. Now I'm just going to follow the same principles as I did in the last exercise. I'm first going to get rid of brackets, so it becomes 2 to the power of 2x minus 2 multiplied by 2 to the power of 3x plus 3 all over 2 to the power of 5x. My bases are now all the same, so let's do it in 2 steps. When I multiply like bases, I'm going to add those powers. So I get 2 to the power of 5x plus 1 divided by 2 to the power of 5x. When I divide like bases, I subtract my powers and I land up with 2 to the power of 1. I would like you now, please, to complete exercise 2, questions 3 and 4, just to make sure that you've understood these principles. It's really important to remember that the exponential laws only work when we multiply and divide bases. So, for example, the exponential law that multiplies a to the 3 times a to the 2, that becomes a times a times a multiplied by a times a, which is why we land up with a to the power of 2 plus 3, which is a to the power of 5. However, if you get an example like this that says a to the power of 2 plus a to the power of 3, you cannot simplify that at all because a squared and a cubed are not like terms and therefore we cannot tidy that up at all. If I was to give you a to the 3 times a to the 3, your answer would be a cubed times a cubed, a to the 3 plus 3, which is 6. If I was to give you a cubed plus a cubed, one of them plus another one of them would be 2 of them. Another example, if I was to give you AB in a bracket squared, that means that we are saying AB multiplied by AB. So our exponential law enables us to write a squared b squared straight away. However, if I give you a plus b in a bracket squared, I cannot use the exponential law and just try and say that it's a squared plus b squared because it's not that. This means a plus b multiplied by itself. And when we multiply out that bracket, we get a squared plus 2ab plus a b squared. Okay, the last 2 examples I want to deal with you. If I give you the square root of 9 times 16, well, I am allowed to break that square root up over the multiply and get an answer here of 3 times 4, which is 12. essentially I'm using the exponential law there that says 9 to the half multiplied by 16 to the half. However, if I am adding those values, I cannot break that square root over the plus sign. This has to be the square root of 25, which is 5. It is most certainly not 3 plus 4, which is 7. When simplifying expressions containing exponents, it's essential to determine when we can use the exponential laws and when we can't. So your first decision must always be, am I multiplying and dividing bases, or am I adding and subtracting? I would like you now please to pause this video and do exercise 3, questions 1 to 6. The most common error that we picked up at the end of last year when we marked your papers is that you get muddled up as to when you are multiplying and dividing bases and can use your exponential laws, and when you might be adding and subtracting bases and therefore have to find an alternative method. I'm going to take some examples now from exercise 4. The very first decision we're going to make in each one of these examples is whether or not we can use our exponential laws. The first example I want to do with you is 7 to the power of 2n plus 1 multiplied by 49 to the power of n plus 1. This example is really very similar to what we did in exercise 2. I look at that and I say, well, the 7 is prime, there's nothing I can do with that. Instead of the 49, and remember to substitute in a bracket, I can write 7 squared. Now, because I am multiplying those bases, step 1 is going to be to get rid of the bracket. So the law for getting rid of the bracket says I multiply exponents, so I have 2n plus 2. Now I'm using the rule that says when I multiply like bases, I add exponents. So I have 2 to the n plus 1 plus 2 to the n plus 2, and my final solution is 7 to the power of 4n plus 3. If, however, the second question looks like this. I have 7 to the power of 2n plus 1 plus 49 to the power of n plus 1. Well, I'm still going to need to write that 49 as 7 squared. So I have 7 to the power of 2n plus 1 plus 7 squared to the power of n plus 1, which, as we've seen above, looks like that. Now, I am adding those two bases. My exponential laws are of no use to me whatsoever in this circumstance. So my target here is to get rid of the exponential notation. I am going to undo my exponents. You see, 7 to the 2n times 7 to the 1 would give me 7 to the 2n plus 1. Once I have undone those powers, I can look at this and say, I have got a common factor of 7 to the power of 2n. If I divide this term by 7 to the 2n, I am left with a 7 to the 1. if I divide this term by 7 to the 2n, I am left with a 7 squared. My target is to get rid of as much exponential notation as possible, so this becomes 7 to the 2n. 7 to the 1 is 7. 7 squared is 49. Get rid of all that exponential notation, and it's 7 to the 2n multiplied by 56. So two very similar looking sums, but with very different solutions. In this first one, I could use my exponential laws because I was multiplying the bases. In the second example, I could not simplify because I was adding unlike terms, and my primary target then is to undo my powers, take out a common factor, and wherever possible get rid of the exponential notation. I want to do two more examples with you just to reinforce the concept. So this is question 3 from the worksheet. 3 to the power of 2n plus 2 multiplied by 5 multiplied by 3 to the power of 2 to the power of n. In this case, all my bases are multiplied. I want to use my exponential laws. I keep this as 3 to the power of 2n plus 2. I'm multiplying by 5, and this becomes 3 to the power of 2n. Where my bases are the same, I'm just going to add my powers. So 2n plus 2n gives me 4n plus 2 multiplied by 5, and that's as simple as I can get that sum. If, however, the question had been 3 to the power of 2n plus 2 minus 5 times 3 to the power of 2n, that minus is telling me that I cannot simplify those base 3's. My target then becomes eliminate as much as I can of the exponential notation. I'm going to undo that power. Now I have a common factor of 3 to the power of 2n, which I can take outside of my bracket. What is left from that term? A 3 squared. What is left from that term? A minus 5. My target is get rid of the exponential notation. So I have 3 to the power of 2n multiplied by 9 minus 5. And of course, 9 minus 5 simplifies to 4. Again, two very different sums with very different solutions. I would like you please now to go to your worksheet and to complete exercise 4. It would be from question 5 to question 10. Thank you.